Okay, just following up from that last question, here are two graphs that relate the number of students and camp revenue in dollars. Which graph could represent the function R? Explain why the other one could not represent the function. So we think about what we had talked about on that previous page. We talked about how the inputs have to be the number of campers, actually going all the way back to page 2 here. The inputs have to be the number of campers in whole number campers between 5 and 16 campers. We cannot have fractional campers. What that means is our graph cannot be connected, right? It has to be what we call discrete, and it has to start with 5 campers, and then it has to end with 16 campers. And there cannot be any connection between those values on the graph because that would be indicating that you could have decimal or fractional people, and that is not going to be possible. So the domain or the x values cannot have fractional people. All right, so the number of students, for example, could not be like 7.5 right here, right? It could be 7, it could be 8, but it could not be 7.5. So there should be no value on the graph at 7.5. You cannot connect those together. There are only these possible values for the graph representing 5 people, 6 people, 7 people, all the way up to 16 people. So, cannot have fractional people. And once again, the domain has to be whole numbers between 5 and 16. Describe the possible output values of R. So now we're talking about the range, in other words, the Y values, which would be revenue, dollars. And so what are the possible revenue values? Well, if the domain is whole numbers between 5 and 16, let's just think about our function here is represented by 40 times the number of campers. So R of n equals 40n. So what are the possible outputs? Well, if we put in 5 campers, then 40 times 5 would be $200. So that would be a possible amount of revenue. R of 6 would be 40 times 6, which would be $240. So that is a possible output. And we would continue to do this until we get R of 16, because that's the most amount of campers. So 40 times 16, if you punch that into your calculator, that would be $640. So the range is multiples of $40 between $200 and $640. So that's how I would generally describe it. But if you were listing out the actual range, you would list out each one of these multiples of 40. So 240, 280, 320, 360. I'm running out of space here, but you get the idea. It would be all of those numbers, but not anything in between. So in summary, the domain of a function is the set of all possible input values depending on the situation represented. A function may take all numbers as its input or only a limited amount. We saw examples of both. The range of the function is all of the set of possible output values. So range output, domain input, possible inputs. Once we know the domain of a function, we can determine the range that makes sense in the situation, like we just did here, but we did need to know the number of campers in order to do that.